Alright, today we'll be looking at some vocabulary and basic concepts of compound probability. So we're going to start off with just some basic vocab, dealing with Venn diagrams in particular. We're starting off with sets. A set is a collection of items. So a group of days of the week, that would be a set of items. So in this example, it's let A equal the set of days in the week that start with T. So A would be the set that includes Tuesday and Thursday. A is just a name for the set. It's not anything to worry about. It's literally just set A. It's just the name of the set. And what the set includes is Tuesday and Thursday. So there are 2 items in this set. Another word for items in a set is elements. Elements are like Tuesday and Thursday, just the items that are included within a set. List of elements are surrounded by little brackets and separated by commas. The number of elements in a set is written as in parentheses, in this case A, just because A was our set name for this example, so we're going to continue with that. But this could be literally any letter or name or word, whatever works best, but this changes. So this is just the number of things, a number of elements inside set A, but again, A could be anything. In the example above, like we just talked about, the number of elements inside the set A is 2, because there's only 2 days of the week that start with the letter T. At the very bottom of this page, we have some symbols to know. We have a member of a set. When you see this symbol, it just means that that item belongs to the set. And then the opposite would be it's not a member of the set. So you just put a line through. A 0 with a line through it or an empty set of brackets just signifies that it's an empty set. There's no information for what we're looking for, or it's just things that are not occurring. And then we have here the universal set. It contains all elements that could be considered in a particular problem. We'll look at each of these on the next page and in the next examples. Okay, so there are 2 types of events that we're going to be looking at for compound probability. They are exclusive and independent events. Exclusive events cannot occur at the same time. So, for example, if you were to pick an even number and a 1 from a set of numbers, you can't do both because 1 is not even, and an even number would never give you a 1. Okay, so you can't do both at the same time. You're either going to grab an even number or you would grab a 1. And this brings us to the OR rule. This is for exclusive events. So for our example, we have 2 events. We have A and B. So the probability of finding A or B would equal the probability of A plus the probability of B. Independent events do not affect each other in any way. So you can do them at the same time because they have no pull on each other. So for example, landing on heads on one coin and tails on another when both coins are flipped at the same time. So if you're flipping 2 coins, it doesn't matter what you get on the first coin. The second coin still has a 50-50 chance of landing on either heads or tails. So these are independent events because the 2 coins don't affect each other's outcomes. This is called the AND rule. So again, for independent events A and B, the probability of finding A and B, that's important there, the and instead of or, is going to be the probability of A times the probability of B. Okay. So this was the this is the example that we were talking about back on the first page of notes, right here. Our universal set is going to be all days of the week, which you can see are listed below. We have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So that's our universal set. Of those 7 days, we're looking for the set that included days that started with the letter T, and so there's only Tuesday and Thursday. And you can see here, set A is shown inside this circle, and it only has Tuesday and Thursday because they both start with the letter T. So that's how you would show a set in like a Venn diagram form. Even though there's not two circles, this is still considered a Venn diagram. So everything that is in set A is shaded, and everything that's not in set A is on the outskirts. We have two examples here. In example 1, list these sets. Okay, so for A, we have square numbers less than 50. So a square number is just a number that can be square rooted. And so this would be a set, remember, has to be inside these little brackets. And numbers that can be square rooted, we have 1, 4, 9, 16, 25, 36. Make sure you're putting commas between each number. And then 49. So that would be all square numbers that are less than 50, and that's again for part A. Part B is months of the year. So again, we're just practicing writing out sets, and we're just going to list all of the months. So January through December. We're going to close it, and we're going to make sure and go back and fill in our commas that we missed. And that would give us set B. Set C is going to be factors of 49, so what you can divide 49 by. 49 can be divided by 1, 7, and 49. Those are all the factors. Example 2, describe these sets by a rule. So what we're doing is we're just looking at what we have, and we're just going to give it a rule, something that describes what we're seeing. So in set A, I have the numbers 1, 4, 9, and 6. And if you look back up to this set, we have a 1, 4, 9, and 6, or 16, I'm sorry. So that set was a list of square numbers less than 50, but we only have down here we only have 1, 4, 9, and 16, it's still less than 50, but if we're going to write a rule for this set, we want it to be appropriate for this set. So I would say that these are still square numbers, but they're obviously still less than 50, but we're going to pick a number closer to what we have here. The biggest square we have is 16, so we can say that these are square numbers less than 17. All right. And then if you look at set B, we have 2 months. We have March and May. These are obviously months of the year. And if we look back at this set B, they are March and May. They are the only 2 months that start with the letter M. So months that start with M. This would be an appropriate description of this set. Okay, and that's the basics for compound probability, vocabulary, and just writing out different sets.